can't expect any security expertise from the teenage girls or from the grandmothers. They will not be able to secure their own computers. So if we are to protect them, security cannot be a box. It has to be a service. It has to be something that the grandmother can just order together with this internet connection, that please secure me, even if that means that somebody then remotely installs an antivirus on my machine, maintains it and configures it and updates it. That's great. That's exactly what they need, and that's what they want. They want someone else to protect them because they can't protect themselves. So if phishing isn't going to get much worse, are we better off then? Well, unfortunately, we're not, because what's going to happen, what's happening already, is that many of the phishing operations are being replaced by operations involving banking Trojans. Trojans like Snatch, Hackstore, Topic, Apophis, Bankos, and others. Trojans which infect your PC and then sit silently on your machine. Instead of phishing scam, which tries to trick you into clicking on a link or going to the wrong website, which looks like the real site, but it's not. Banking Trojans don't work like that at all. You get hit by a banking Trojan because you go to Google, you search for something, you click on search result number 6, and you end up to a website which is an evil website. Which it was in the Google to begin with because it just has lots of index keywords and it has an exploit on the front page waiting for you. And since you're running a little bit older version of Internet Explorer, you get infected like that. And you never noticed this. You just got hit, and you have no idea that you got hit. Or you received a banking Trojan in an email attachment. But regardless, you get infected by one of these. And what it does after you get infected is that it does nothing. It just sits on your machine, sits and waits. It doesn't display anything. It doesn't try to trick you into going into a bank. Nothing like that. Just sits and waits until 6 weeks later, 3 weeks later, 2 days later, you decide that, oh, I got to go online to do some banking. And you type in the address of your favorite bank, and that's when the Trojan wakes up. I know that URL. That's a bank. And then it will either steal your credentials when you're logging in, or if the banks have improved authentication, like all the big banks here in Malaysia do. So you have key fobs, physical devices, one-time passwords, or SMS text message authentication. Then if it has that, it simply waits until you log in, and it will insert extra transactions. You go online. You go online to pay bills, and you pay 4 bills, and the Trojan will silently and invisibly insert a 5th bill, which, from the point of view of the bank, looks like you typed it in yourself. But you don't see it on your screen at all. It was inserted to the HTTP stream by the Trojan. And the encryption in the banking connection doesn't help at all, because it's SSL. It's already decoded by the time it hits your browser, or it hits your screen. And the malware is operating as a browser handler object within your browser. So in the end of the transaction, you approve the bills. You never see the bill, but it will move a few thousand ringgits from your account to the criminals. What did you do wrong? Nothing. You went to the right website. You were using the same bookmark for your bank you've always been using. It is the right URL. It is HTTPS. There is the lock. The certificate is right. There's nothing wrong on the screen. And they still got your money. So how on earth are we going to solve that problem by educating users? We won't, because there's nothing to educate. The only thing they did wrong was that they got infected by the malware to begin with. And that can happen in so many ways that it's just hard. Of course, I could recommend everybody to buy our antivirus, which is a great idea. Go and buy it today, but that's probably not the solution you want to hear. These banking Trojans are commercial operations being developed by a few Russian and few Brazil gangs that develop and sell banking Trojan toolkits. So these guys probably aren't doing a crime by themselves, but the actual groups that are buying and using these Trojans are the actual criminals. This is SE Code selling the Snatch toolkit. The previous one was the Hackstore authors. I think I also have a Visual Breeze somewhere, but probably here, not on this set. How are we doing in time? Since we started a bit early, should I still finish in time, or should I keep going until 11? Organizers, you have an opinion? Sorry? Oh, sure. Then in that case, I'll show this example as well, because we seem to have the time to do it. I find this particular case fascinating because it involves one of the few cases where you were actually able to track down the malware author simply based on his computer evidence. We have here the very first example of the WMF exploit when it was found in, whenever it was found. It's an image file which contains an exploit. When you view this image in an unpatched Windows computer, it will exploit your system DLLs, cause a buffer overrun, download an executable and run it. The image header has been corrupted on purpose or modified on purpose, and the actual code starts pretty much from here. And as you can see, or actually as you can't see, it's encrypted. There's no obvious way to see it's encrypted, but trust me, it's encrypted. And it's encrypted with a very simple 8-bit XOR, where you run the XOR operation against every byte with the value 97. And I know it's 97 because we disassembled this back then. Just trust me, it is 97. So, we can go here with the tool I'm using here. Here, you can easily just decrypt simple encryptions like XOR. Now I'm decrypting it. As you can see, it doesn't look much different at all, but it is now decrypted. You can actually tell that it's decrypted if you watch carefully, because right here, there's a URL. You see that? It says http unionseek.com/d/ioo.exe. That's the part, that's the code it downloads and runs. It's not online anymore. But if we keep decoding, then we'll find this mysterious string, which is hidden in the end of the code. String which says 0600 KO78RUS. And this was just sitting there in the code for no reason whatsoever. It wasn't used for anything. But it was still encrypted. And we were looking at this, trying to figure out what is this? Why is it there? So we Googled for it. We Googled for 0600 KO78RUS, and we got 0 hits. But then we noticed that it ends in RUS, like Russia. And we have plenty of Russians in our lab, so we talked to them. Do you know what is this? And they had no idea. But one of them said that 78 is the city code of St. Petersburg. For example, you can find it from the phone numbers when you dial St. Petersburg. So we did some digging, and we found this Russian hacker site called securitylab.ru, where people were discussing this particular vulnerability. And those of you who can read Russian can see that from here we have a guy who's commenting about this particular vulnerability. And he seems like have like inside information. And his nickname was SP0Raw. And we did some digging, and we found his homepage. This guy was operating his personal homepage, which runs in English, Chinese, and Russian. And he's offering different services from his site, and he also has a link to his personal blog, which is running at livejournal.com. So we read the blog to learn more about this guy, and we learned quite a bit. We learned, for example, that he is 21 years old. We learned that he lives in St. Petersburg. He has a 20-year-old girlfriend. He likes Pepsi Cola. And we learned about his car, because he has a very nice car. This guy is driving a V12 S600 Mercedes-Benz, which is a very nice car, especially if you are a 21-year-old kid from the city of St. Petersburg. How did we learn about this car? Well, because he blogged about his car, complete with pictures, because he had a car crash. He crashed his Mercedes, that's his Mercedes, into a Lada Samara in downtown St. Petersburg. And he blogged. These pictures are from his blog. Now, if you look carefully to this picture of the crash scene, if you pay close attention, you will be able to see that this guy's license plate number is 0600 KO78RUS. If this would be a court, I would now say, I rest my case. But it's not a court, because in court, bad people go to jail. In the real world, they often don't. Here's an example of that. We provided all this information and all this intelligence to all of our contacts at different law enforcement, including law enforcement in Russia, Scotland Yard, Secret Service, and FBI, already quite a while ago. And nothing's happened. As far as I know, nobody has even spoke to this guy. As far as I know, this guy is still driving on the streets of St. Petersburg in his Mercedes-Benz. Or perhaps he's upgraded to a BMW by now. Who knows? One thing that does worry us in the lab quite a bit are these targeted attacks. I mentioned in the beginning of my presentation that the first evolvement was from hobbyists to criminals. The latest evolvement is the addition of spies on top of the criminals. Targeted attacks are espionage attacks. Espionage or spying. Like, what is spying? What is spying in the end? Spying is the act of collecting information, right? All right, what is information? Well, information used to be on paper. It used to be in books and binders. It used to be in the safe of the office. And spying that information involved going to the office, reading the papers, or photographing the papers, or plans, or stealing them, copying them. Today, data has replaced information. Information is data. Data is portable. I have here 2 gigs in my hand, which would be enough to store all of our email for the past year. And I can just put it in my pocket and walk anywhere and out of it. So the sheer movement of data has totally changed. And of course, it also means that, at least in theory, that information is now available remotely from anywhere in the world. And that's what we're seeing with these targeted attacks. Traditional malware infections involved the malware being distributed to random places, anywhere. So the fact that if you got infected, yeah, it was bad, but it was only bad luck, because everyone else got infected as well. You were not alone. The fact that it hit you is just bad luck. Cases like targeted attacks mean that the fact that you got hit means that you are targeted. No one else got the malware. No one else has ever seen the malware. You were hit because somebody is after you and your information. And this, of course, means that the targets are not, it's not like you and me. It's like big companies stealing information from large international corporates. And the way it works is that somebody sends an email to one guy or 2 guys or 3 guys in one organization. For example, the chiefs of the R&D department. They get an email which typically would look like an internal email. Like it's coming from someone else in the organization, from someone they know. And it looks perfectly real. It's coming in a normal company letterhead. It has the company signature, some real person in the company. They talk about real things. And they talk in your local language. For example, we've seen these in Germany, auf Deutsch, in the local language. We've seen them in Sweden, in Swedish. So you get an email from someone you know in your organization saying, "Hi, Jim, the customer meeting in October is quickly reaching. Here's the first agenda draft. Could you have a look?" And there really is going to be a customer meeting in October, and you know the guy. Are you going to double-click on the Word document he's sending to you? Of course you are. Makes all sense. You double-click on the Word document. It contains an exploit which was not detected by the antivirus you're using, because these guys know which antivirus you're using. They've modified it to be undetectable by you, and crashes your Word, launches an exploit, pops up Word again, and loads up a document which looks like a real document, talking about real sensible things. You just got infected by a targeted Trojan, which now is hidden by a rootkit, sits on your machine, and tunnels out through Internet Explorer, connecting to an IP address somewhere in China, sending out information from your computer and from anywhere in the network that you can access from your computer. And we've seen cases where companies were hit by something like this, and they had a few key infected workstations within their corporate network for 18 months before they realized that somebody was downloading information from their network all the time. These are the real nightmare cases. Now, these are really rare cases. We only know of a handful of these happening around the world over the last 2 years. So it's really unlikely that this would happen to your company. But when it happened, it is a real nightmare case. You got hit, it was targeted, it was prepared, somebody put a sizable investment in attacking you, and most likely they will be successful. So we've seen these around the world. We've seen big companies being targeted. We've seen governments being targeted. We are aware of attacks against EU Parliament, the UK Parliament, and the German Ministry of Interior